Now, the next topic that we will talk of is the angular bisectors of two given lines. What does this mean? Suppose we have two lines and they are intersecting. Now, we are interested in finding out, obviously they will make two angles, either this, if this is theta, this would be 180 minus theta. Obviously this will be again theta and this would be 180 minus theta. What we are looking for is to find the equations of the angular bisectors, or rather this is the angular bisector, that is a line which will bisect this angle, and there will be two such lines, that is this is bisector, let's say 1, and this is bisector 2. What is it doing? It is bisecting this angle. Now if this is theta, this would be theta by 2, this is also theta by 2. Now if we take this as 2 theta to avoid this fraction, let's take 2 theta. This is, let's say this is theta and this is theta, and obviously if this is 2 theta, this whole angle will be what? 180 minus 2 theta. Therefore this would be what? 90 minus theta and 90 minus theta. If this is line L1 and this is line L2, we are interested in finding the equations of B1 and B2. So what is angular bisector? Angular bisector is, it is the locus of points which are equidistant, from the two given intersecting lines. What does this mean? It means, now if we have two intersecting lines and we want to find point or points which are equidistant from these two lines, that is a point whose distance from this line and this line are equal, and when we say distance, it should be the perpendicular distance. Now there will be lots of points whose distance from these two lines would be what? Equal. If we take this point, this distance will be equal, and so on. Similarly, there will be points on this side also. These distances will be equal. Matlab, this distance equals this distance is same as this. Now if we join all these points, what we get? We get a line. And what is the property of this line? This property will divide this angle. Why? Let's see. If this is the line we are talking of and it is equidistant from these two lines, L1 and L2, we see that since this distance, let's say this is P, this is A, this is B, this is O. So in triangle AOP and triangle BOP, we see that AP is equal to BP because the point is equidistant from both the lines. Now OP is common in both the lines, and this is 90 degree each. Angle PAO is equal to angle PBO. Therefore, by RHS criteria, these two triangles are what? Congruent. Therefore, this angle will be equal to this angle. Therefore, this line is doing what? This is bisecting this angle. Therefore, it becomes the angular bisector. Similar will be the case for this line. Again, all these points will be what? Equidistant from these two lines. Again, we will be able to prove that this angle equals to this angle. Therefore, angular bisector is the collection of points who are equidistant from two given lines. Therefore, all the points lying on this line will be equidistant from these two lines, and all the points lying on this line will be equidistant from these two lines. Therefore, these two represent what? These two represent, and we have proved that they bisect the angle between the two lines. Therefore, this forms the angular bisectors. Now we are interested in finding out the equations of these two angular bisectors. Now we already know that the distance of a point from a line, let's say this is h comma k and this is ax plus by plus c0. Therefore, if we want this distance, we can find this out by bringing all the terms of the line on one side and substituting these points ax, h, bk plus c and dividing by square of the coefficient of x and square of the coefficient of y and take the mod. Now if this point is, let's say, x comma y, and the equations of these two lines are given to us. Let's draw this. These are our two lines, L1, a1x b1y plus c1 is 0, and let's say this is L2, a2x plus b2y plus c2 is 0. Now we are interested in finding the locus of points which are equidistant from these two lines. Therefore these perpendicular distances are equal. Let this point be x comma y. Now what we will do, we will find the perpendicular distance a2x plus b2y plus c2 whole divided by a2 square plus b2 square, and put the value of xy as x and y itself. Now this distance should be equal to this perpendicular distance. Let's say this is a, this is b. This is representing PA. Now what would be PB? a1x plus b1y plus c1 upon under root a1 square plus b1 square, and we have put the value of x and y as x and y itself, arbitrary points. Now if we remove the mod, we have a, or rather we can write a1x b1y plus c1 upon a1 square plus b1 square plus minus a2x plus b2y plus c2 whole divided by a2 square plus b2 square. Now this represents the equations of the bisectors, equations of bisectors of the lines L1 and L2. If we take positive sign and solve, we get one equation, and if we take the negative sign and solve, we get the other equation. Now if you look closely, under root a1 square plus b1 square and under root a2 square plus b2 square are constants. Therefore we can rearrange this as plus minus a1 square b1 square upon a2 square plus b2 square, and this is a2x plus b2y plus c2. Now if we consider this to be a constant, let's say lambda, what is it written? a1x plus b1y plus c1 minus plus, everything can be taken to the left side, lambda times a2x b2y plus c2 is 0. Now if you remember, this is line L1 plus minus lambda L2 is 0. This represents equation of line passing through the intersection of two lines, and this is exactly the case what is happening. Now what would be this? The equation of angular bisector is passing through the point of intersection of L1 and L2. So we can say, first point, the angular bisectors will be what? Pair of lines. Why pair of lines? Because there are two lines. One we will take with positive sign and then we will solve it with negative sign. It is pair of straight lines passing through the point of intersection, passing through the point of intersection of lines, given lines L1 and L2. This is point number 1. Before going on, let's take an example to understand this. Let's say we have an equation. Find the equation of angular bisectors of the lines x plus y plus 4 is 0 and 4x minus 3y, or this time we'll take, let's say, 12x plus 5y plus 4 is 0 and 4x minus 3y plus 4 equals to 0. Now what was our formula? 12x plus 5y plus 4, bring every term to the left side, divide by the square of the coefficient of x plus square of coefficient of y is equal to plus minus, bring all the terms of the other equation on one side, divide by square of coefficient of x and square of coefficient of y. So what do we get? 12x plus 5y plus 4 upon 13 is equal to plus minus 4x minus 3y plus 4 upon 5. Now solve these equations one at a time, taking positive sign. Let's say first, cross multiplying it, 60x plus 25y plus 20 and this would be 52x minus 39y plus 52. So therefore, taking every term to the left side, 8x plus 64y, and taking 20 to the right side, we have 32. So dividing by 8, we have x 8y equals to 4. This is the equation of first bisector. There will be two bisectors. This is the equation of one of them. And if we take the negative sign, we have 60x plus 25y plus 20, and the signs would get reversed, 52x plus 39y minus 52. If we take xy terms to the left side, we have 112x minus 14y plus 72 is 0, and we can divide by 2. We have 56x minus 7y plus 36 equals to 0. This is the equation of the other bisectors. This is how we find the angular bisectors of two given lines which are intersecting.